All right, let's jump into what we call a geometric sequence. Make sure to have this down. This is pretty much a 100% thing that you will use again. We must have this down. It's going to start working into sequences and series. The next part, which we haven't done. Please make certain you understand geometric sequences and geometric series. Let us go. So I'm not going to give it to you right away. I just want to give us some examples. Now, all I want us thinking is will this converge or will this diverge when we take the limit as n tends towards infinity of a sub n? Is this going to converge to a number, or will this diverge to a number? Or to not a number, like goes to infinity or goes to negative infinity. My apologies. So we're looking at this, but I don't actually want to calculate the limit. I'd rather just look at the sequence. You mind? Can we just look at the sequence? So I just want to talk about it so we can see where it's going. And I think it's a little easier for us to look at the sequence. So we get 1/2 to the first. What's 1/2 to the second? What's 1/2 to the third? What's 1/2 to the fourth? And so on. Dude, I think it's doing one of these. Like if this is a half, a fourth, an eighth, a 16th, a 32nd. Does it look like it's going towards something? Yeah, it looks like it's converging to 0. Looks like it's going to converge to 0. Cool. Well, what about b to the n? You think that one's going to work? Think that one's going to converge to a number? Let's try. Let's plug it in. 3 to the first. 3 squared. 3 cubed. 3 to the fourth. 3 to the fifth. I don't know any of the numbers past that. Does that look like that's going to converge? Like this one back here converged, didn't it? It looked like it converged to 0. Over here, it looks like this diverges. It looks like that number is going to blow up without bound. There's no bound to stop it. Therefore, it diverges. Now let's look at another one. C sub n. And we'll look at this one. Be like, well, let's just plug some things in. Negative 1/2 to the first is negative 1/2. Negative 1/2 squared is positive 1/4. Then we get negative 1/8. Then we get positive 1 over 16. Then we get negative 1 over 32. And then it keeps on going. Now, if we were to graph this thing, well, what's your n and your C sub n? Well, we get negative 1/2, no big deal. And then we're going to get 1/4. And we're going to write all the numbers in. But we'll start doing something like this. On both sides, it's getting closer and closer and closer. Yeah, one goes from negative to positive, but it looks like that thing is getting smaller and smaller. All those magnitudes of the numbers are getting smaller. Therefore, this will converge. It's converging to a number. It just happens it's converging to 0. That's going to be a big thing for us. And then lastly, we start writing out some terms. The first power, that's negative 5. Then we get positive 25. Then we get negative 125. Then we get 625. And then I've ran out. I don't remember them. Now it goes negative to positive, right? Negative, positive. But look at the magnitudes. Aren't they just getting larger and larger and larger? Therefore, this is not bounded at all. And it will diverge. That's our game. Well, notice what we've done. All we've done is taken a number and raised it to the nth power. This is, I'm struggling. This is what we call a geometric sequence. So we're looking at something like this. R to the n. R to the n, where we're concerned with the R. That's what we're looking at. We're looking at this. We want to know, hey, if n starts at 1, it goes up to infinity. Where are we going to go? So let's write it out this way. And here is a theorem. Theorem for geometric. Sorry, I didn't copy this over, but it's not that big of a deal. Geometric sequences. Please, please, please know this. So we're going to let R is a real number. So we're not dealing with any i's. So that's the first case. As long as R is a real number, we have this. The limit as n tends towards infinity of r sub n. Just some number, like up above. Our r was a half, then it was 3, then it was negative 1/2, then it was negative 5. That's the r we're talking about. Well, this is going to equal one of three things: 0, 1, or dne. One of the three things. If the absolute value of r is less than 1, it's going to go to 0. If r is equal to 1, well, come on, man, it's frickin' 1. It's just 1. And then lastly, if our if our r is greater than or equal to negative 1, oops, I wrote that backwards. Sorry, got that backwards. If it's less than or equal to negative 1, kind of like over here, negative 5. Negative 5 is less than or equal to negative 1, and it diverged, didn't it? Or if r is greater than 1, it's going to diverge. It will diverge. So as long as whatever is in here is a gosh darn fraction that's in between negative 1 and 1, don't include the frickin' endpoints, it goes to 0. Because anytime you take a fraction, take a fourth. That's squared, it's 1/16. Take a fifth. Squared is 125 smaller. It's going to get smaller and smaller and smaller. So I get so gosh darn excited. So here's kind of the game for our inputs. If this is r, we're going to say negative 1, 0, 1. Make a hole here. So if we're in between negative 1 and 1, don't include negative 1 though, we will converge. This is the inputs. This is r. If that r is in between negative 1 and 1, it will converge. Notice that the positive 1 it converges for, but negative 1 it does not. And then we will diverge if the input, if the base is outside that range. So if r is less than or equal to negative 1, it also diverges if r is greater than 1. That is something we must have down. So just real quick, I give you this sequence here. 0.9 to the n. Does it converge or diverge? Well, 0.9 is in between negative 1 and 1. That converges. If I give you a 5/4 raised to the n, that diverges. Because 5/4 is bigger than 1. And what about this one? What about negative 1 to the n? Does that converge or diverge? Well, r equals negative 1 would make it bad, so that also diverges. So there is our first. We'll jump into geometrics. We will do a geometric series, which will become highly important. And then we're going to jump on into it, okay? So we're almost done with this section. Lots of words, and then we're going to move into series, which the rest of our section is going to have to do with. And we're going to need to learn the difference between a sequence and a series. Sequence, we just look where the numbers are going. And then we move into series, we're going to start adding them up. All right. I will see you in the next.